derivatives. And I hope one thing that you notice is there's u's and u prime, because now that I've done chain rule, I have to recognize that this might be a function within a function. And so that's just the u prime there is like just, hey, I got to make sure I multiply by the derivative. Why is it on the top? Well, because if you put something behind a fraction, isn't it the same as putting it on the top of the fraction? So like when you look in our textbook, I'll have to take a look what they do, but they might have it at like the du at the end. So really this is like 1 over the square root of 1 minus u squared times du, just in case, like if this was a 3x in here, then it would be times 3 or whatever, and I could put the 3 on the top. So the 3 that you want to focus on that are on your AP exam, I have not, I might have seen this one on the AP, I'll go check, but those 3 are the most important. Here's the deal though, I want to show you some similarities. What's the relationship between arcsine, or arctan, for instance, and arccotan? What's the only difference? Look at arctan and arccotan. That it's negative, and that kind of follows if you think, do you remember how tangent and cotangent, the cos were negative? Interesting. Fun. There's similarities to these two. If you look at arcsecant and cosine, they have some similarities. There's an absolute value of u. But for now, we're going to just focus on these. I'm going to show you from yesterday how we can get those. You don't need to derive them. I just want you to understand, hey, how is this related to derivatives? Because it's like all of a sudden you just whammo see these formulas. So I am going to start with one of my trig functions. I'll do arcsine. Would you guys write down for me y equals arc sine, and we'll just do of x. Okay, one note today is, let's go back up at the top. What's another way of writing arcsine of x? Or arcsine of u? Yeah, so these derivatives apply if it's written either way. If you see arc cos, I always forget the 2 c's, arc cos, that's the same as cosine inverse. Arc tan of u is the same as tan inverse. So just as you're aware today, all of a sudden if you see it written this way or that way, that's means the same thing. In fact, hold on. Do you have your little 2019 handy test? It says it, I think, right on the front of it. Yeah, does it say, if you look somewhere, flip over a page, does it say, like, it usually tells you. Yeah, okay. Yeah, it tells you at the top of the exam on page 3. It says, hey, in this exam, arc sine x equals sine inverse. So basically you might see them either way. So, all right, so let's draw a triangle. Let's do what we were doing yesterday. I'm going to just show you how you can get to this top expression. So we draw a triangle. And I'm going to draw the triangle. If arcsine is x, that's like x over 1, right? What's the ratio of sine? Opposite over hypotenuse. So I'm going to make x go opposite, 1 go hypotenuse. What's my expression for this piece then? Good. Square root of 1 minus x squared. Okay. Now what we're going to do is we're going to take this expression, realizing that that triangle is what we represent there. And if y equals arc sine, that y is this angle here essentially, instead of theta. All right, so how would I use the inverse property to get that x out of the arc sine? Let's take the sine of both sides. So I take the sine of y equals the sine of the arc sine of x. Because they are inverses, what that does is it cancels the sine arc sine part out, and we're left with just an x equals sine of y. Ooh, find dy dx. What is this? This is just implicit differentiation. Let's find dy dx. Let's take the derivative of both sides. What's the derivative of sine? Cosine, but it's of y, so afterwards I'm going to multiply by dy dx. So cosine of y dy dx equals, and what's the derivative of x? Okay. What would I do to both sides? Divide by cosine of y. So, but now dy dx equals 1 over cosine of y. That doesn't help me out. I need it in terms of x. Yep, but it still would be secant of y, and that doesn't help me out. Remember, y is this angle up here. That's why we drew it. Y equaled this angle right here. Could we look at the triangle and write an expression for the cosine of y using the triangle? The cosine would be the adjacent over hypotenuse. So it would be this over that, but it's on the bottom of the fraction, so I can just rewrite it as, I have the 1 still on there, right? That's from there. And then the cosine is this over that. Do I really need a 1 on the bottom of that? Okay. Look at the very first one on the top of our list. I just derived the derivative of arc sine. That's what I just did. Okay. Do you have to derive the derivative of these? No, I'm simply showing you how it's related to what we did yesterday. Okay. No, you don't have to do any of that. I'm showing you, if you would do this with a triangle and write it as x, how you could take the derivative of both sides and get this from our triangles yesterday. The only difference was we just did it with x. So you might say, well, where's that derivative on the top? Well, that's just the derivative of x, which is 1, so that's why I have a 1 on the top. Okay, how are we going to use it? Let me show you a few examples. Okay, so you're going to want to go back. And yes, you are going to memorize just like you did with your Trig, so these are going to be some flashcards. Or make a Quizlet. Some people did that last time. So I'm hoping that you're seeing that the function is arc sine. I'm going to, from the front, write the general equation for the derivative. I'm going to put u in there because that's how it's written, and I'm going to point out to you what u is. The derivative of arc sine from the very top is u prime, that's just du, over the square root of 1 minus u squared. U just represents the function. So in this case, u is t squared. So that's what I'm going to put in my u spot. And I'm going to need to multiply by the derivative of u, though. What's the derivative of t squared? Okay. Technically, it's 2t dt dt, but again, since I started with that, that's fine that I can leave it as 2t. All right, so we put it all together. What are we going to put on the top? What was our u prime? It's 2t. On the bottom is 1 minus u squared. So that's 1 minus t squared squared. What's another way of writing that? 1 minus t to the fourth. Multiplied. In this case, I mean, I know what you're saying. You get the same thing, right? But you were asking me what the rule was. Yeah. A power to a power, you multiply them when they're multiplied. Like if I did t squared times t squared, that would also be 4 because they were added. All right. What if I have a trig function on the inside? This is just an example of chain rule. We'll go nice and slow, guys. So the good news is that way on the inside, at least I have a t. But I have this outside rule that I have to do first. Ooh, dig back deep, guys. Who remembers what is the derivative of tangent? Secant squared. Good, Dylan. All right, so, but now I'm doing chain rule, so I have to not change the inside yet. So I'm going to take the secant squared, and I'm not changing what's in the inside. So of arc sine of t, if you want to put an extra parentheses. But now I have to multiply by the derivative of what's inside, which is the one we just learned. The derivative of what's inside is this. Here's the nice thing. It's just a t, and I'm taking the derivative with respect to t. So the t here, the derivative is just going to be a 1 on top. So 1 over the square root of 1 minus t squared. Okay, let's review now. If we have something like this, what goes on the top of the fraction and what goes on the bottom? Good. So I shift that to the top, and then I put it over the square root of 1 minus t squared. Okay. I'm going to show you once you can kind of see how AP assesses it. It's not a huge topic. You'll probably see at least 1 or 2 multiple choice questions where you have to do it. But typically they do one with chain rule, and it usually isn't a super big chain. So I took this example, it's my last one, off an actual exam. I don't think it's the one we did. We can look in a second. Yes, ma'am. Okay, so this is actually the function squared. So the function squared, since the function in here is t, so it's t squared. And this one, the function was t squared, so t squared squared was t to the 4th. Okay? All right, so let's say I gave you the function f of x equals arc tan of 4x. And I wanted the slope of the tangent line at x equals 1/4. Okay, what's slope of the tangent line code for? Derivative at 1/4. Okay, so we're going to do the derivative, and then we're going to plug in 1/4 to evaluate it. Ooh, but you have to know the unit circle. All right, here's the nice thing. They usually give tan inverse of nice ones like 1, where it's pi 4 or something like that. We don't get too ahead of ourselves. Okay, look up arctan from the front. So arctan is, here's my function. Whatever the function is, it's the derivative of that function and 1 over 1 plus u squared. Okay, so I'm going to write that down here. Okay, so what's our function? What's our inside function here? 4x. So when we're doing the derivative of that, there's going to be a 4 on the top. And when we're squaring that, we got to make sure we square 4x. Okay? So f prime of x equals, on the top, we're going to put our 4 over 1 plus u squared. So I'm going to write 1 plus, in parentheses, 4x squared. Be careful, that's not 4x squared. What is it? 4x times 4x. So it's 1 plus 16x squared. Ooh, I didn't even actually, if we did the tangent line, I'd have to find the y value, but I didn't even ask for the tangent line, I just asked for the slope. So now what do we plug in? Let's plug in the 1/4 to find the slope of the tangent line. So we do that. It's 4 over 1 plus 16 times 1/4 squared. What's 1/4 squared? 4 times 4. 1/16. What's 1/16 times 16? 1. The slope of the tangent line is just 2.